Hi and welcome back to the follow-up video for our 1700 euro Regner Cooling Case. The one with like special built-in water cooling, which is made in Germany. Today we will finally finish the build. So we will have the components sitting inside. We will also first do a comparison loop. So build up a normal custom water cooling loop, take temperatures of the water temperature of CPU and GPU. So we have some comparison values to check out how the cooling performs in comparison. That's something we will do. Also, there was some discussion going on about the Made in Germany logo. And then I was reaching out to Regner Cooling again to verify like which components are actually made in Germany and like is everything made in Germany or not. And then he also sent me some pictures of the manufacturing process, which I'm not allowed to share unfortunately, but I verified that the main parts, so like all the metal, like the bent metal sheets, the painting, like the inner chassis and also the main components of the radiator. This is actually not only one piece. So he showed me it's made out of several pieces with CNC milling inside of the structure, and then it's like sealed together. All of these main components are actually really made in Germany. So I verified that and everything is okay from my perspective. And I mean, if like, let's say a fan grill or maybe the USB hub is made in China, sometimes it's just not possible otherwise, and that also wouldn't really make sense to manufacture it here if it already exists and you can just buy it as an existing part. But for now, we will like remove the case and then build up our first like comparison water cooling loop. I finally also received the C690 formula board, and when I received it, I was also questioning myself, like, why did I even buy this? Because I mean, we're not going to see the board. And I paid 700 euro for it. Could have also bought just a 300 euro board. Not sure why I did it. I don't know. Videos and projects like this always involve high investments. And that's only possible because we have very supportive and great sponsors, such like Hetzner. And I want to inform you that currently Hetzner still has a special offer for the dedicated AX servers, which feature AMD Ryzen CPUs without setup fee. For example, for the AX41, which is using the Ryzen 3600 and 64 GB of memory, you will save 39 euro. And for example, if you use the AX101, which is featuring the Ryzen 5950X and 120 GB of ECC memory, you will save even 99 euro. Hetzner is currently also celebrating the 25 years anniversary of their business. Congratulations from my side, and currently Hetzner is running a giveaway for the celebration, and if you are a customer at Hetzner or a future customer, then you can participate in the giveaway. You can, for example, win a TV or some drones, so that should definitely be interesting. You can find links for the giveaway and also for the AX servers in the description down below. Then I also have to admit, after taking this out of the box, it's just an absolutely beautiful looking board. And it also has VRM cooling potentially available, like water cooling. I will have to figure out how I will integrate this into the cooling loop, but I will definitely find a solution for that. And I will also have a 1200 KS in there. But I will also be completely transparent that this is a sample. And if it wasn't a sample, I would just go for a K CPU and not a KS, because the KS is so much more expensive for the additional few percent performance. And yeah, we will just use this for video editing, so it wouldn't make much sense to go for a KS instead of a K. There's also this M.2 hypercard included in the box of the main board. It's not that I want to use it. It would allow to use more M.2 drives. I don't need that, but with this I wanted to point out that even if I wanted to, I could not use it. Simply because the case does not have expansion slots. The only way you can have any kind of expansion card is for the graphics card over the riser card. But everything else, like utilizing any additional expansion slots, will not be possible. So putting the CPU in the socket. Memory-wise, I decided to go with this 6400 C38 kit, simply because it seems to help quite a bit using fast memory on Alder Lake for video editing. I have some benchmarks for you, which we can check out later. I bought an EK magnitude as the CPU cooling block, and I already know that some people in my Discord will instantly freak out that I bought the block for 200 euro. But then I never used it personally. I know that performance-wise it probably doesn't really make much sense, because you can also get like an velocity block and it has pretty much the same performance. But then it might be just a different build quality, but as I said before, I personally never owned one, never used one, so I was just curious and wanted to test it once. Definitely seal of approval for bundling the correct thermal paste. There's definitely some room for improvements for some of the accessories though. Even though you might not see it, but I mean for this price, because the painting seems to be not perfect on some of these parts. But for the block itself, just from a pure manufacturing point of view, I mean, that's perfection. It's like nothing you could improve anywhere. Awesome. I'm pretty happy with the magnitude. I mean, just the way it's mounted and all the quality, it's a pretty solid product. We'll see how it turns out performance-wise. Also mounted the SSD already. I went for an MP 510 simply because I just don't need a faster drive. I picked this one with 2 TB. In the end, we will still be limited by the performance of our NAS because we're cutting everything over network, and the NAS is delivering a speed of like, I don't know, like 800 MB per second. And as long as we're quicker with the SSD, everything is fine. So that's more than enough, and like a Gen 4 drive, a quick one, would just be a waste of money. Not so happy with this part, with the tube in between. I decided not to go for a single hard tube because it would somehow look lost in there, I guess, because everything else will be done with tubes. But then, I mean, there's like a tiny height difference, and the gap in between both is very small, so you can get a, yeah, like a heavy bend in the tube. It should work, but it's not beautiful. I also had to extend these fittings with those titanium looking ones because I didn't have the black extension here, but yeah, it's not perfect, but should work. This is our first comparison assembly. You can see the C690 board with the graphics card. Everything is completely assembled. And we will start with a single 360 radiator combination, simply because we want to have more than one point for comparison. So we will later add a second 360 radiator. At this point, I also want to highlight that in between here, there is 30 millimeters of clearance. And I already tested this like ages ago, that the performance impact will be 0 if it's pointed towards the table or like a surface if there is 30 millimeter of clearance. 20 is on the edge, but 30 is enough clearance underneath here that the air can breathe through without any performance impact. You could also lift it up, it would be the same kind of performance. Cooling loop wise, we will start going from the radiator and pump to the CPU block, then through the VRM, through a temperature sensor. And we will later just have to pay attention that the order will be the same and also that the temperature sensor will be at the same place. And then it's going through our VGA. And now we will have different load scenarios. For example, CPU load only with about 200 watt. Then you could have a mixed load with like gaming. So it's maybe like 80 or 90 watt on the CPU and more load on the GPU. And then also a full out load scenario. But before that, I have to perform a USB BIOS flashback. And I'm not even sure if that's going to help me, because I had some trouble getting the board to boot. Okay. I really hope this helped, because otherwise this will definitely screw up my time schedule. Even though I'm now booting from the iGPU of the CPU, it is still progress, so seems not to be damaged or dead. Now everything is working. I already did the BIOS settings, so launched XMP profile, then set the CPU to 5.1 on the P cores and 4 GHz on the E cores. It's a pure static OC, which also means that the voltage is static at 1.25 volt. This will result in a bit higher power consumption, especially in gaming. It's probably like 15 or 20 watt more than if you would leave the CPU on auto. But we just want to have like fixed values that will make the temperature comparison a lot easier later on. And we can also check the water temperature is already 35 degrees Celsius in idle. But I mean, it's a 6900 XT and a 12900 KS with a single 360 radiator. That's, yeah, not enough. We're starting with a quick spoiler regarding temperatures, running the single 360 radiator and gaming load for 30 minutes. You can see the water peaked out at 47 degrees Celsius, even though it was just a light gaming load. You can see the GPU max power draw was below 300 watt. But I also want to point out that Igor's lab was doing a good investigation about the power reporting on AMD cards. So it's very likely that the real power draw is about 20% higher, which would mean that we're more in the region of about maybe 350 watt under load for the GPU itself, while the CPU load was peaking out at about 100 degrees Celsius. And the CPU was still quite cold though. You can see not even 70 degrees Celsius peak, but 47 degrees Celsius on water. With this light gaming load, that is quite a lot. So a 360 radiator definitely is not enough, but that was clear right from the start, I guess. So that's why we have to extend the loop by another 360 radiator. I decided to go for the new heat killer one, which looks quite nice. really beautiful, very, very nice quality. And I will equip this one with 3 Arctic P12 fans. But now finally going back to the case itself, as you can see, I dismantled both of the radiators on the side, which reveals a case that's a lot tinier than before. But still, after the first video, a lot of aspects have been unclear to you and also to me, especially when it comes to how is it built internally, how do you mount the GPU, how do you mount the board, and what does this mean for the cooling concept itself. So this means we will now remove the front, the top part, and also the thing on the back. Behind the front, we have 2 140mm fans, which are like exhausts. They are blowing outside of the case. So from my understanding, the cooling concept should work the way that you have the radiators on the side, and because the openings of the lamellas are on the bottom and on the top, it will like suck in air here, and this way maybe assist the cooling apart from the natural convection you would have in the passive radiator on the side. That was my first thought, but then I saw that the back fan, which is also a 140mm fan, is an intake fan. And this would kind of not work with the theory I had, so I'm not quite sure. I might as well also try swapping this fan or like turning it around and see if this benefits or like impacts the performance. Inside the front panel, we also found an RGB strip. After removing all these covers, you're basically left with this part on the right, which is keeping in the 2 fans. On the left, 1 fan, and here in the center, the mainboard tray, which also houses the I/O panel and also has the riser cable going all the way through. Now a quick look at the back of the case, and this is the cutout where all the mainboard connectors would go through. And if you look closely enough at these parts, like the I/O area of the mainboard and also the I/O area of the GPU, those are 3D printed parts. Same thing goes for the PSU shroud, which you can remove after removing the back part. And to be fully honest, I'm not sure about this, because I mean 3D printed parts, fair enough, but as long as you don't use like a 50,000 euro 3D printer, this will always give you some kind of like prototyping vibes. Like the quality of 3D printing will never look like it's, let's say, like a milled part. If this was like a milled part, it would be so much nicer. Then underneath the area where you would mount the GPU, there is a spot or like 2 spots for 2 2.5-inch SSDs. This is very well made, like very well placed. And also the cables are good quality. Same goes for like all the other cables which are included, like the I/O area cables, USB cables, all nicely sleeved black. That's something I really like. I quickly want to go back to the I/O area, the I/O panel. That's what we talked about already in the last video, because nothing is like in line, nothing is on the same level. Now I unscrewed it and you can see that it is sitting on a single PCB. It could be that they made the PCB themselves. Doesn't really matter though, but you can see because they are using like 3 different connectors, obviously, like USB-C, audio jack, and USB 3.0. And because they're all sitting on one PCB, like the 0 point is on the bottom, and because they have a different height, the connectors, this explains why they are not in line. But that might also be a good chance, because this is also a 3D printed part. Could be that this could easily be fixed, and I think it should also be fixed. Since there was also a bit of confusion about how the cooling inside is working with the different fittings and everything, I decided to completely take it apart so we can also look at how the cooling was meant to work out. Because from the front you can only see this aluminum panel and 2 connectors, which should be for filling. And then internally you have 8 connectors, which should be for the loop itself. And if you pay close attention inside here, you can see that there's some sort of glue inside, which means that it's probably CNC milled out of 2 aluminum sheets, because this is aluminum. And then it's glued together. Then I also found an RGB controller, which was laying inside here. And to be honest, I'm not quite sure why this is included. The reason might be though that the RGB strip used is not compatible with normal PC hardware, because this is not like a 5-volt addressable or a 12-volt non-addressable. It's something in between, because it's a 12-volt 3-pin. Not sure why they went with this. I mean, it would have been so much easier to just go for a normal like 12-volt or like a 12-volt 4-pin or a 5-volt RGB addressable. By the way, in the manual, it's quite well documented to figure out which connector is meant to go to which component. Regarding the PSU, I'm just about to add this Thor from ASUS, latest generation. Very, very beautiful thing. Unfortunately, we will not be able to see the power draw on this one in this build. Doesn't really matter though. But regarding the PSU mounting position, I would have loved if they had cutouts in the bottom with maybe some dust filter for the PSU. I know I'm usually not a friend of dust filters, but for the PSU and on the bottom might make sense, because otherwise you might intake some of the dust. But there's enough room for intake in the bottom, otherwise the intake will be from the top here. There's definitely some progress building in the case, but it's also a huge challenge. There are several aspects which are quite difficult, and especially everything cable management related. You can see there's a huge mess down there, which is not really an issue because later on this will be closed with a PSU cover. From this cutout right here, we will be able to route our 24-pin cable, so that's fine. But then we cannot do that with the EPS connectors, simply because the cable will be too short. We could probably do the same with the EPS connectors, but then, yeah, it will go all the way, all across here. It won't look nice. You have to ask yourself the question, does it matter that it will look nice? Because on the other hand, it will be a fully closed system. We will not be able to look inside, so probably it won't matter. But then I was also wondering if we could just remove this back plate right here, the second, I would call it mainboard tray, the back part of it, because then we could route the cable through from the bottom, have them come out here and close it again. Routing them through without removing the plate is not possible because the gap is too tiny to route the connectors through. And generally speaking, the case is missing a lot of cable management options, like just having tiny notches on here where you could attach cable ties and stuff. Nothing exists, so that should definitely be changed. Some more progress, as you can see, the VGA is now sitting inside the system. It was also a bit more complicated than I expected, simply because of the way the VGA is mounted and how much clearance you have inside the case. First of all, you have this metal sheet right here. I'm not sure if this is part of the SSD mounting, but because you have this metal sheet right here, it is practically impossible to plug in your power cord to the VGA if it's already installed. So you are originally supposed to mount the card while the case is standing upwards. And that's a bit complicated because you will not be able to plug in the power connectors afterwards. That's why I just laid it down on the table. Will make it much easier. And then you slide in the card to the riser cable and then have it fixed using this small thumb nut. It actually took a full afternoon building the entire system, so it really took a lot of time. Also, assembling everything again with the tubing for those side panels takes a lot of time. And now I will have to remove the front panel because behind that we should get access to the reservoir for filling. One aspect about filling is that I have no indication how much fluid we actually have inside the system right now. That is impossible to tell because there is no indication, and you just put it right in here, and then once it's full, it will instantly leak. So that's a bit inconvenient. This basically means I will have to switch on the system and then fill it up, or keep filling it up, I guess. But even then, I will never figure out whenever I will reach the max. Alright, first leader is in there. Not sure why I didn't think about that in the first case, but obviously in that position it will be much easier. I can tell you guys, I'm having a lot of fun. Like really a lot of fun. Can you see this? Post error. And while checking the debug code, you can see it's like D6 or D7. The VGA is not getting detected. Good thing that we're using an Intel CPU that has an iGPU. For debugging is going to be a lot easier. Luckily, AMD CPUs next gen will also feature this. My first guess is that the riser cable could be dead. Yeah, I have no other choice than replacing the GPU, so I just put a testing card in there where I know for a fact that it's working. I mean, we also used this one before and should be fine, but you never know. Still same thing, post error, also same debug code. Yeah, the only conclusion is that the riser cable is broken. I have to admit I'm a bit frustrated because now it's like Tuesday evening for me and I started working on building the PC like Sunday morning, like Sunday noon. And now, like, the riser cable is broken. I'm not sure if I want to blame Regner Cooling because this could be something that could happen to everyone, that a part you're sourcing externally is broken. So yeah, hard to blame anyone for this, but it's still quite frustrating. And I also checked the cable itself and it said HLX link. And if you Google it, you can find an AliExpress store and there are only 3.0 cables listed with 60 centimeters. And as far as I know, there are no 4.0 cables that exist with this length because of the signal integrity. And I don't think that 3.0 to 4.0 currently is a big deal. Shouldn't have a huge performance impact with a strong VGA, maybe like 3 to 4%. But now that RTX 40 is about to launch and also the RX 7000 series could maybe have a bigger impact, but just a wild guess. I don't know. I'm just lucky that I also performed a CPU only benchmark when I did all the water cooling pre-tests. I did like 3 3D tests, like load scenarios, and I did one CPU only load scenario with like 200 watt load. I'm very happy that I did it because now, even without an VGA, we can at least get at least one comparison number, which I will probably do overnight or tomorrow morning. All right. The system has been running in idle for about 1 hour just to even out like all the mass that can be compensated of the radiators and also the huge amount of water. That's why I wanted to wait for a longer time period, and now the water temperature is pretty stable at 36 degrees Celsius. The first temperature chart we're looking at now will be about the render load with about 18 minutes between 200 and 220 watt on the CPU. First, we're comparing a single 360 and dual 360 radiator combination. The single 360 peaks out at about 40 degrees Celsius max, whereas the dual 360 is more in the region what you would typically want to have with water cooling between 33 and 34 degrees Celsius. Now, if we add in the Regner Cooling Case to the chart, you can first of all see on the left that the idle temperature is a bit higher by about 2 to 3 degrees Celsius. And also under load, we see the same kind of difference, about 2 to 3 degrees Celsius higher than a single 360 radiator combination. Also now, I added this white line, which indicates the point where the test is over. And after that point, you can see that the normal radiator combination drops quite quickly in temperature. Whereas the Regner Cooling Case doesn't really drop down, it stays almost the same for minutes. Before we get to the final words regarding the cooling performance, we will do another test, which is rotating the fans in the front. And then 3 more hours of testing, 1 hour staying in idle, 1 hour under load, and then 1 more hour cool down. I'm still wondering how the fan direction will affect the cooling. My first guess was that if all fans are blowing inwards to the case, that it might help the convection on the radiator to push the hot air outside on the top. That's why I will flip these around and then we will see what happens. To be fully honest, I don't really see why it would make much more sense to continue testing. It's been like 35 minutes in XTU stress test. Current CPU power consumption around 190 watt. So that's about the heat we're dissipating to the loop. Add a bit more from the VRM, so maybe it's like 220 watt dissipated to the loop, but let's check. And it's still 48 degrees Celsius. I mean, that's best case, like 1 degree better than before. So it doesn't really make much sense continue testing. I didn't spend the time adding the second line to the chart. It simply didn't make any sense, because if you look into this, the 1 hour XTU stress test, you can see that after 1 hour, the fluid temperature is already reaching almost 50 degrees Celsius. 50. That is really a lot. And I mean, if it's 1 degree less or more, that's like almost measuring tolerance, especially like the room temperature might change a little bit. And then, yeah, the result will be the same. And now going back to the 360 radiator thing, in the end, the entire case cools worse than a single 360 with low speed fans. Because when I was testing on the single 360 radiator, I had the fan speed normalized to 40 dB, which means they were probably running at like maybe 900 to 1000 RPM. So not really high. So not really high cooling solution or high cooling capacity from a single 360. And this cools worse. Which also means, like right now, we were only running 200 watt load. Only the CPU. Now imagine that we would also have the 6900 XT in here dissipating the heat into the loop. Additional at least 300 watt, maybe more. Now think about like a 3090 Ti. It's impossible. It's like impossible to cool. It will not work out. And like 50 degrees Celsius fluid temperature is already reaching the point of some water cooling components, like the max operating temperature. There are several pumps, several blocks and like other components which have their max operating temperature at like 55 or 60 listed. Some or most components don't list a max operating temperature, but for the fluids, for the pumps, typically this is like between 55 and 60. Like above also doesn't make any sense. Because if the fluid is already at 60 degrees Celsius, how is it going to cool the CPU or the GPU? I just don't see how this is going to work. So there are two more claims on the website I want to talk about, because in the end, it will depend on how are you going to market the case. Like what was it built for? Is it built for the fact that it's just a nice design and has some sort of cooling? Might only be for office purpose because it's nice to look at, but not really for gaming maybe. But then if you look at the Regner Cooling homepage, it's just German. But basically if I translate it, it tells you that it's an innovative computer case with integrated cooling solution. And it tells you that the case is extreme in any regard. And it has the best possible cooling solution with the lowest noise possible that was ever available. And that's simply not true. Like this is below a single 360 radiator. And that is far from being the best cooling out there. Like that it couldn't be further away, right? And then the second claim they have on the website is the performance goes up, the temperature stays low. And then there are some more claims in there that it's like a massive amount of cooling, and even if you want to push the maximum out of your CPU, aka overclocking, that it will deliver the best possible cooling. And now the 1 hour test I was running with XTU, the 1 hour stress test, the CPU was clocked 5.1 gigahertz, 1.25 volt, and it was constantly thermally throttling. And this is below the typical stock 12900 KS operation. It's below that. So not even stock, it would be able to keep up with the performance. I just don't get it. I just don't get it. Like how can you come up with such claims and then it's so far away from reality? Like I would understand if there were maybe like 2 or 3 degrees. I don't know. I don't even know what to say, but this is so far away from reality. Like, I don't know. This is so bad, really. This cannot cool anything. It can cool a CPU for office purpose without a GPU, and that's it. And reaching such a point of a product, this is always where I'm questioning myself. Did somebody ever test this, or was this just a PC render? Because honestly, if you ever built a 12900K system in there with any VGA, even if it's just a 3060, you would have realized that it's not going to cool the way it's intended or marketed. I just don't get it. Like, did somebody before me ever build in there? I don't know. Now it's time to get to the probably, I would call it the most interesting part, because to be fully honest, I have a lot to complain about. And during my build process, I took a lot of notes, like things I figured out, things which are not working fine and everything. And now there are several things we have to talk about. So first of all, the I/O panel. That is something a lot of people already talked about in the first video. Also, like most of the comments on the German video were like, for this price, they expect a perfect inline I/O panel. And I totally agree. Then I also reached out to Regner Cooling and told them, so what's your plan regarding the I/O panel? Do you plan to like improve it or upgrade it? And unfortunately, they said they want to sell what they have in stock and then improve it afterwards. And to be honest, that's not how you should do business. That's not how things should work out, especially not for this price. That's something I also had to learn over the years. Sometimes you learn it the hard way. But if you make a product and you figure out that something is not working out or users are complaining about it, you have to fix it, especially if it's still the early stage. I mean, if you made 100,000 pieces, then it's maybe too late. But like in the early stage, and I'm probably the first and only person that has this case. In this stage, it's expected that they fix some things. Fixing things. One thing, the paint. If you look at the paint in the first second or the first moment, you think this is a beautiful looking case and the paint also looks very good. That's the first impression. But then if you get closer, you look at the edges, then you see that on some of the edges there's almost like no paint, and like on the edge there's also like a bit of a paint buildup. And that's something you can see if the edge is not perfectly smooth. Like if you have, let's say, a stamped piece of metal, then you have very sharp edges. On a sharp edge, the paint will always build up. So you have to grind these edges to make sure they're a bit more round, a bit more smooth, to prevent paint buildup. That's something they should definitely change. And since it's always custom painting, it means that the raw parts should not be painted right now. Maybe it's still fixable. The side panels are extremely inconvenient. If you're building in a case, like if you get it shipped, then you always have to put both side panels on a table. It takes up a huge amount of space. You don't have really space for working with the case, which means that there should be a way to remove them entirely. Quick connect fittings would be awesome, would make your life so much easier with this, because I had to remove the panels by removing the AquaCool fittings on there. And I hate those AquaCool fittings because they are so hard to rotate. Like they're so tough to rotate that you need like pliers or something to remove them. So it takes, I don't know, like 5 minutes per side panel, and then the fittings are scratched because of the plier use. Not a fan of that. Then there are those tiny pieces of, I think it's called Velcro, like very soft things on the side. I guess they are to prevent scratching from metal on metal, and also to make like putting on the side panel a bit smoother, the experience itself. That works out well. Like the feeling you have while sliding it down is very nice. But then if you have it taken off and you look at those tiny pieces, it seems like they're all cut by hand and they all are different shapes and sizes, which is not cool. I'm not sure if that's the most elegant way to use this material. It's something that definitely works on a technical perspective, but also here it should be improved. They all should be the same shape and size. RGB controller, that is something I totally don't understand. Like, why is an external RGB controller included? You have to control over your phone. You don't even have to make your own RGB software or anything. You just have to go to AliExpress and buy any random RGB strip that you can connect to your mainboard directly. I mean, it doesn't even have to be 5-volt addressable. Even the typical old school 12-volt RGB strip would work with 4 connectors. But this one, for whatever reason, is not compatible. The thing in the front, the entire pump and reservoir combination, is also something I completely don't understand. It's made out of 2 pieces, at least 2 pieces of aluminium. It's milled and it's glued together, which will make any kind of maintenance like impossible, because you will not be able to open this. In case you have some, I don't know, like bad fluid or whatever, like some corrosion building up and you want to clean it, you cannot clean it. I also don't understand why they even went with aluminium in this position. Just go for POM, like acetal. It's so much more convenient to mill, like just the processing is so much easier. You don't have to coat it, you can just buy a black one. And then you make your like additional groove, put some O-rings in there and you're done. And you can have perfect, like you could even have a piece of acrylic in there, like a tiny window to see what the fluid level is inside the pump combo. Yeah, that would have been better. But for this part, aluminium, I don't get it. Generally, the filling process itself is terrible because you have no indication of how much fluid is inside. And then you could see it. It's a wonder that the fluid didn't just drop down over the board and inside my PSU and just kill the entire rig. Like, that's not great. It should be improved as well. In the bottom of the case, you have 2 PSU shrouds, left and right, which are necessary for accessing the cables from the PSU for the entire cable management. And after you're done, you're closing those with 2 PSU shrouds. The screws of the PSU shrouds are too long and they are directly pushing into your PSU. So now I have 2 nice grooves or scratches inside my new Thor PSU, which is nice. And also the entire like PSU clearance inside for sliding in the PSU was not enough. Even already at sliding in the PSU, I noticed that the case is already like scratching on the PSU. The clearance is not enough. There's missing like 1 millimeter. Cable management itself is terrible. There's like no cable management option whatsoever. Even the cheapest case has some kind of notch where you can hook up some zip ties or whatever. Like in here, even though you don't see it, but you always have to keep in mind, even if you don't see it, it will block your airflow inside. It will potentially make your cooling worse if there is no cable management. That's why it should be done even if you don't see it. 3D printing parts in a mass production case. I don't agree with that. That's something you can do for a prototype. It has strong prototyping vibes. At Grizzly, for example, we're doing that on a daily basis. If we're printing like new direct die frames or like the lidders and stuff, before we CNC mill it out of aluminum, we always 3D print it, simply to check if everything is in line. That makes total sense, right? But as a final product, price performance wise, or like price appearance wise, that's not in line for me. For a price tag of 1700, which got increased to 1900 now, by the way, I don't want to see any like 3D printed parts in there. Could only be me, but I would have expected perfectly CNC milled parts. If you want to fill up the case, you have to remove the side panels in order to remove the front to access the filling points, which is very inconvenient. I'm not sure how to do it more elegant, but it should be improved if possible. So there are many points, as you can see, which are far from perfect, and I mean, it definitely needs a rework, definitely needs to get more testing. As I said before, I don't understand how this reaches my table. I mean, I just bought it, right? It's not a sample, I bought it, and then I thought we would maybe build our render rig in there, but the cooling capacity is so far away that it's not going to be possible. I like the concept of the case though, like just the way it's built, it's beautiful. It's a beautiful looking case. But the concept of cooling needs to get some strong improvement. Also like the fan directions, I'm not sure about that. It just didn't make sense for me, even though we didn't really see a difference now, but that might also need some further improvements. In the end, I mean, also the riser cable was a bit unfortunate, I guess. Probably also better for them because, I mean, there is no way that the 6900 XT would have worked in there, like cooling wise. Yeah. By the way, now it's like Wednesday afternoon and I woke up in the morning, had a bit of like a scratchy feeling in my throat. Did a test, staying positive, awesome. Not so much, but so I just forced myself to finish this video because I wanted to have it done. And now I will go to bed. I will probably stay in bed for a few days, so there will be no video on Sunday, I guess. So yeah. Thanks for tuning in. Till next time. Bye bye.